Bismillahirrahmanirrahim. Welcome to Easy Learn. Here we are discussing the network analysis. This is a complete series. Welcome to episode 6, and here I will want to recap first before going to discuss the capacitance parameters. So let us discuss the episode 5, what we discussed the content in the episode 5. We are basically developing the circuit conceptual scheme, and we will follow the three same steps for the each of the three parameters. That is the discussion of main theme of episode 5. I discussed three parameters there: physical phenomena, fields interpretation, and last circuit interpretation. So these are the three different things that we are going to discuss in the next in the coming episodes and in today's episode, one by one. But there is a technical thing that there are two type of circuits we discussed in the previous episode. There are, number one, capacitance parameters. Those circuits who have capacitance in usually in common, or capacitance is in more than the inductance, while those circuits who have more the inductive parameters are called inductive parameters, are different because inductors have different behavior and totally reverse than the capacitive parameters. We are going to discuss each and every parameter in details one by one. We started from the basics, from the charge from episode 1, and now we are in the episode 6 and moving toward the capacitance parameters. So let's discuss the capacitance parameter first. So first is the physical phenomena. In this physical phenomena, basically the presence of the charge on two separate spatially spaces means that two spatially separated substances means that there are the two charges. One is a positive, another is a negative. We are separating them in a medium, like in air or in atmosphere. This is called that looks like that there is no link between them. It is in such a way we are going to separate two charges. Causes an attraction at a distance in the form of the force between two substances, means there is an action of the force. Actually, if there are the charges like this is a positive and this is a negative, like in the form of the plates or in the in any format, there are the two opposite charges or like charges. There are the different type of the cases. Like the first case says that it may be the positive charge with the positive, negative with the negative, like charges, while it may be the opposite. But first is the physical phenomena, when we are just taking a look on the physical behavior, that if two charges are bring closer to each other, like they are coming toward, either they have no physical contact, no physical contact, like wires is connected here or nothing else, then what happens? Basically there is a field lines actually that we can represent. There is a field, there is an area that any charge has surrounded. In surrounding, it has its own region where it can attract or repel. Basically it can experience any other charge in that area. So like these are the positive charges, this round shape basically here representing the area of these positive charges, while the negative charge is downside here in the diagram. The round ellipse shape here basically is for the representation of the jurisdiction. In the physical phenomena, first step, we are just noticing their physical movement. Either they are showing any deflections, their movements, they are coming closer, attracted or repelling. Like if you remember, this shape shows that, like if snakes type magnets, though two magnets that are used for the fun, available in the market. So I played when I was in early childhood. That you, if throw these magnets in the air, they produce this very beautiful sound, and sometimes we enjoy these. Anyhow, the discussion is we are watching the physical behavior. When the two charges are coming closer, there is a positive or negative. This phenomena we regard as a property of the nature. We are not doing anything with it. This is just a natural fact, and we have to admit that there must be a movement, there must be an attraction or the repulsion. Coulomb told us actually this thing, that when the two charges are coming closer, there must be a physical movement can be seen. This is called the force. Force means a power, attraction, repulsion. This is the force between the two charges. Like if there, this is the charge, and this dotted line I am drawing, this is the region of the first charge. If any other charge, like here, suppose this is a negative charge, and this another charge coming to the region, and over, this is the overlapped region. When the one charge and other charge come into the overlapped region, then what happens? This is the case that Coulomb told at first notices. That is why we are always taking into consider the charges measurements in coulombs. Unit is coulomb. That is actually named after the scientist. Coulomb found that the nature of this charge is such that like charges are always repelling. They are always going to repel each other. They are going in opposite direction because they are maybe don't like each other. They are always hate each other. Why the unlike charges, like if it is a positive and it is a negative, they always wants to attach with each other. This will wants to go this side, and here in this position, when they come here, they are going to be joint family. They become a I'm just kidding. That force varied according to this equation, very nice equation. F is equals to q1 q2 4 pi epsilon r square. Here remember that this is the force where we are going to calculate in the Newton's force is measured in the Newtons. Q1 and Q2 are the two charges. Like let's just draw another story. This is a first charge that I am drawing here. Let's call this a Q1, and there is another charge. Let's call this a Q2. If let's measure the distance between them in the form of meters, and we call it as a r. The force of attraction or repulsion between the two charges is definitely will be high if they are bringing closer to each other, and if their distance in the meters is increased, the force will be decreased. This is a very basic and the theory that everybody can understand. The repulsion forces, attraction forces, if you are going to separate them, then definitely magnets or any charge can't attract or repel each other because they have a limited jurisdiction. If you are going taking the other charge away from that, unfortunately they can't extend their ability to go through it. Anyway, q1 q2. So from this numeric from this formula, you can see also the relationship is valid. Like F is equals to q1 q2 or 4 pi epsilon r square. So F is inversely proportional with r, not only inversely proportional with r but the square of r, which means that if you are going to increase the area, the force is decreased double time. Square, because actually square comes because they are the two charges. So distance is in the form of the squares. Both comes from the double effect. Not interested in the derivation right now, but Q1 and Q2 are the two charges that can be measured in Coulomb. Like if it is a 5 Coulomb charge or 10 Coulomb charge, we can definitely substitute the values here to calculate. R can be calculated in the form of the meters. 4 is understood in, just substitute all these values in the formula. Pi, it is an irrational mathematics numbers that it can be like 22/7 is equal to 3.14. While E, this is actually a stylish E here. It is the we can simply call here that is the permittivity, having a free space, permittivity of the free space. Like we are performing this experiment on Earth, definitely on free space. Mostly this is the free space, but sometime in numericals, to confuse you, they often call that, suppose that we are performing this experiment on vacuum, on space. So this is changed according to the area. According to this depends, because the air has their own effects. If you go through the area where the magnetic fields are available, and they always have in the region that is in contact with the other magnetic field, and then definitely their permeability also affected. So Every permittivity has on specific value, but you must remember this one, that the permittivity of the free space is 8.854 8.854 into 10 raised to power minus 12. This is measured in Faraday per meter, F by M. This is the actually the standard MKS system. Q1 and Q2 are the charges that is measured in coulombs. So it should be understood that this equation applies strictly to the point charges only. However, the equation may be applied to any geometry of the non-charge distribution by vectorically, means this is a vector quantity. Like if this is a point charge having a force of, let's suppose, 2 Newton, and we can have another charge, so vectorically form we can add them like in the mathematics for their algebraic sum. Okay, let's move towards the field interpretation. That is our second point when we are going to develop a circuit and wanted to any calculations there. The field interpretation would be the second step that comes in front of you. The phenomena can be described in terms of force on a unit charge placed the two charged bodies. Like this is the first charge body, first charged body, and here is the second charged body, second charge body. It has its own jurisdictions, boundaries. Second charge body also have its own boundary. If there is a point charge, point positive charge, we place here, like this is a positive point charge. Then what happens? There is a phenomena that can be described in terms of the force. Interesting thing is in terms of force, like it may go toward this side with a force because it can experience a force. It can go either in this way, it can still experience a force. The force must be there, it can be physically seen. There is a phenomena which can be seen in terms of the force. So this unit charge that is placed between the two charged bodies is experiencing a force. This force is the force per unit charge, that is the force. This force on this, that is this is actually a unit, this is our unit charge. So the force that we are experiencing on this unit charge is actually a vector quantity, because the force is a vector quantity. Force has a direction, particular direction where it is in this direction the force is acting, and that's why it always have also a particular direction. Interestingly, this electric field is now we can say the force per unit charge. Simply force per unit charge, Q is the charge, F is the force. Electric field can be defined is equals to very simple formula, is equals to F over Q. This is the second formula that you need to write down in your notebooks right now. E is equals to F over Q as a conceptual aid. Just for understanding purpose, let's go to the next slide. We can draw the specific lines, the field lines that may represent here, like this is a positive charges, this is a plate that contains mostly positive charges, here is the negative end. If we are going to draw the lines for our conceptual purpose, we are going to, that cannot be seen actually, they are just conceptual purpose. Magnetic field lines, these are just for used for the conceptual schemes. They are not, they have no concept actually in the physical world. As a conceptual aid, we are just using the physical that can be represented with the help of these lines. The direction of the force that we would be exerting on a unit positive charge, this can be exploring charge at each point. Since in the previous slide we discussed that two charge bodies, that there is a positive charge that is placed experiencing, this unit charge is basically experiencing a force that basically exploring charge at each point. So these can be these are the actually lines that are actually field. This is the field lines that we can draw here. That's why it is actually experiencing a force. We are just wanted to show you that what what is the reason that it experiences a force, because there is a charge body here, there is a charge body here. There is no physical connection between them. Why it is going to attract, repel, going toward the one side or other side, then why? Basically there is a field, magnetic field lines. If we're going to look closer, there are the field lines that are present here that are responsible for this forceful action on a unit charge. So we can say that these lines are conceptual. They should not be thought of as actually being present. These equations that we derived today, not derived, just discussed today, like the first equation, F is equal to q1 q2 over r 4 pi epsilon r square, and the second very simple but yet beautiful equation, E is equals to F over Q. Remember these equations, and this is the end of episode 6, and we discussed the third and important parameter, the circuit interpretation, in the next slide, next next lecture. Because I may divide the lecture into two parts still. In the next episode, in the episode 7, I may discuss the half portion, because this is a little bit tougher. I wanted to pay more attention so that all students who have a little bit weaker, or you can say their level is a little bit low, we especially wanted to take care of those students in our series, so that they also join the classes and do not feel any hesitation by asking questions. So this is the end of episode 6. We will discuss the further discussion in the next class. Take care. Allah Hafiz.